In this video, we're finally going to conduct the hypothesis test that we've been itching to do for 2 videos now. So the first video, we found that this was a dependent sample, then we found the differences using our calculator, then the statistics on those differences, namely the mean and the standard deviation. Then in the second video, scrolling through, we found the null and alternative hypothesis. The alternative in particular is very tricky. In chapter 11, the words like less than and greater than don't mean what they meant in chapter 10. In chapter 10, less than always was left-tailed, but in chapter 11, not so much, right? It depends on what I set up to be group 1 and group 2 in the problem. Then we saw that there would appear to be a difference that would mean we would reject the null hypothesis, and we saw that we had all the requirements met in order to conduct this test. So now we're actually going to conduct the test, amazingly enough. So we're going to need all our steps. Now, luckily for us, we've already figured out step 1. Step 1 we figured out in the previous, well, about 2 pages ago, which is that the mean for the differences has got to be greater than 0. And again, it's a little strange, but reduction in this case meant a greater than. All right, step 2 is very simple because it says right here alpha equals 0.05. Level of significance means alpha. It's the probability of making a type 1 error, if you'll recall from the first section in chapter 10. So that's easy and done. Now, step 3, we need to find our test statistic. Let me go back to show you this. Right, so the test statistic is T0 is this formula right here. So that's d bar over SD over the square root of n. But remember, we found d bar to be 1.923 and SD to be 1.605. So that would mean that we have to divide, oh, and n is 13. So we need step 3. Let me grab that. There we have it. Now I found it to be 4.319, but let me prove it to you. And you can do it a couple ways, but what I want to do is run the test in the calculator. So let me remind you, at the top of this page, it tells you right here that you're going to conduct a t-test, right there. So we're going to conduct a t-test. So we'll go to Stat, we'll go to Tests, pick number 2, t-test. And because I entered that data into L3, I can actually use data. Now in this particular case, because I've run the data, it actually knows X bar and S. So I could technically use stats even if I wanted to, but I'm going to use data just to remind everybody how to do it. Now the mu0 value is the value from your null hypothesis. And if you remember in chapter 11, it's always the same. It's always 0 right there in the null hypothesis because you always assume that there's no difference. So you enter 0. Now my list is not in L1, it's in L3 because L1 was my before, L2 is my after. So I'm going to hit second 3 and that'll be list 3. Frequencies we always leave as 1, that's a more advanced topic. And then you have to very carefully pick your hypotheses, and in this case we want a greater than. So I'm going to go over here to the right hand side and choose the greater than one. And I'm going to go down to calculate and press enter. And there I can see my statistic is 4.319 right there. So I get that test statistic from, I'm going to make a note, from the t-test output. Right, that's where it comes from. You could type it in yourself, but students tend to not do it correctly because it involves a division of a division, which usually students are not very good about putting into a calculator. So there's how to do it just with the t-test, and that's all you really need. You don't need to do it by hand or anything. All right, next we need the p-value. So let me go back to that calculator output for a second. And you can see right there it says p equals 4.986 e negative 4. Well, that's scientific notation. It means that the decimal is actually 4 spots over to the left, right? So let me type that up. There we have it. Now I drew the picture. Let me go show you the inferential statistics sheet. We're doing a p-value approach and we're doing a right-tailed test. So it's this picture over here on the right. You have to put down your t0, which was 4.319, and you shade that little bitty tail. It's going to be very small. And that p-value is 0.0005 essentially because the 9 would round the 4 up. And actually after the 9 there's an 8 there. So it's very much higher than what we have right there. All right then, so we've done step 4. Step 4 is pretty simple. You just put your p-value down, label it with the arrow, and put your t0 that you found in step 3 right there. Now we need to make a decision about rejection or not rejection. So remember that in the p-value method, let me go back, you reject H0, your null hypothesis, if your p-value is less than alpha. P-value method's easy because you're always looking for a low probability. Well, this p-value we found is definitely lower than alpha. Alpha was 0.05, and that p-value is far less than 0.05. So we are going to reject the null hypothesis for sure. And that's what we do. So we reject H0 because our p-value was less than our alpha. Right? P-value being 0.005, alpha being 0.05. And that leads us to write our conclusion, which is step 6. So if you reject H0, that means that you did have enough evidence to support the claim that their average pain level is lower after Reiki therapy. And that's what we write. There was enough evidence. Doesn't mean that it's true. It just meant that we had the evidence to prove that. Not to prove it, to support it. Right? We never really prove anything. Prove implies that you're 100% sure, and we're not 100% sure. But we did have the evidence to support the claim. All right, now we're going to redo this, but with steps 4 and 5 from the classical method. And again, because you don't know what's coming on the exam, I could ask you to do a p-value method test or a classical method test. But the rest of the steps are exactly the same. The only thing that's different for classical is steps 4 and 5. And for my money, classical is actually much harder than the p-value method. So you're doing a right-tailed test right here. So you're going to label it T alpha and alpha. Now notice that's different than the p-value. P-value is T0 and p-value. But for this, you're going to need T alpha and alpha. And you're either going to use inverse T or the T table with your degrees of freedom equal to n minus 1. Okay. Well, our degrees of freedom will be 12 because there were 13 data points in our sample size. N was 13. So degrees of freedom will be 12, and alpha, we said up here in step 2, was 0.05. And since we're doing a right-tailed test, we're not actually going to lose it or split it in half or anything. We're going to use all of 0.05. Now, if I grab the T table, which is over here, there it is, T table, and I want to go to the 0.05 column and the 12 row, I can see the degrees of freedom right there is 1.782. Or excuse me, the critical value is 1.782. All right, so I'm going to type that up 1 second. There, and I drew the picture right here. So we have our alpha equal to 0.05. Oh, that's really small. Let me fix that 1 second. And I apologize, I can't actually make an alpha and a t at the same time. So I mean T alpha, which is 1.782. And that area right there is alpha, which is 0.05. I don't know why I have this arrow over here, but I need to make that go away. There we go. All right, so now we found that with, you could find it with inverse T as well, by the way. Inverse T if you do 0.95 because this side is 0.95. Or you can do 0.05. If you do 0.05, it'll just give you the negative value, and then you have to know it's a right-tailed test, so I need positive 1.782. So now step 5 is a little confusing in the critical or classical method. You're doing a right-tailed test. You'll reject H0 if your T0 is greater than your T alpha. Now T0 is what we found in step 3. It's 4.319. So you have to ask yourself, is that greater than the T alpha critical value we just found? So your test statistic, which is T0, is greater than your T alpha, you will reject H0. And it is, so you will. There we go, I wrote that up. You reject H0 because your test statistic, which is T0, is greater than your critical value, which is T alpha. And I put in the values there. All right, there we go. We've now conducted a test, both the p-value method way and honestly the classical method way. So be prepared for either one to show up on your exams. All right, and then we'll see you back here for the next one where we'll go over hypothesis testing again, but the next time will be with a computer output.